I'm John Gomm. I work at Sanraki High School. I teach chemistry and some maths too, but chemistry. So we are talking about silicon and implanting into silicon. So my activity is called silicon implants. There's a bit of amusement there. And first I start with the model of silicon. This is just a regular diamond structure built from a organic carbon system, but it works for silicon. So this activity is a model of implanting ions into silicon chips. So as our implanted ions, our models are metal balls or marbles. And as our model silicon chip, we have some jello. And so we are going to implant balls of various sizes into the jello as a model of how engineers put atoms of various types into their silicon chip. So one of the problems engineers have is keeping a consistent depth. So how deep do the ions go, and they do that by controlling how fast they go, because how fast they go dictates how far they penetrate into the jello. Students kind of grasp that relatively quickly. And so the activity starts off with them just having jello and the balls, and they get to like throw it at the jello and miss usually. That happens quite a bit. But when they get a good splash, you can see that the ball goes into the jello, and you can see a damage trail behind it, which also happens in the real microchip. You get damage trails. After a while, the student should come to the conclusion that the throwing the balls either doesn't get enough energy into it, or is inconsistent, and the balls go at various different depths. So the next part of the activity is to get them to make a more consistent energy of impact.